This is it.
This is it. This is it.
Is the most important document in the history of astronomy.
It's the most important image ever taken in astronomy.
Wow.
VAR. Our frontiers expanded forever with the 3 letters on a glass plate. Equally fascinating is how we got there. Women. They expanded our pursuits in astronomy and opened up new possibilities, new frontiers. Women were responsible for creating the analysis of stars on astronomical photographic plates. Our incomplete understanding of the universe is limited to what we see. Just 5% of the universe's energy, and that understanding would have remained even more incomplete without the efforts of the underpaid, unrecognized group of women who were at the forefront of astronomy a century ago, who became known as the Harvard Computers. By 1880, astronomers had only mapped 13,000 stars. Using the various methods, they were able to map the distances of stars up to 300 light-years away. However, there was no way to measure distances of stars, no scientific way of classifying stars or understanding the composition of stars. William Fleming was amongst the first of the Harvard Computers. In 1890, she published her study of nearly up with 16 categories of star spectra. She used alphabets A through Q based on decreasing hydrogen absorption. In 1897, Antonia Maury expanded on Fleming's work in her paper Spectra of Bright Stars. Miss Maury figured out that the O category lines, Orion lines, were an indication of helium in the stars. Today's classification system is based on her ideas and those of her peers. Miss Maury's groundbreaking work represented a broad new frontier in astronomy. Their champion was Edward Pickering, the director of Harvard Observatory, who used photography to transform astronomy. With photographic glass plates, Edward Pickering built a team of human computers who analyzed the glass photographic plates for breakthrough discoveries. With a constrained budget, Pickering hired female workers because he could pay them half as much as men. These women are known as the Harvard Computers, and they transformed our understanding of the universe. The leader of the next generations of the Harvard Computers, Annie Jump Cannon, switched back to alphabets in 1912 and simplified the categorization to OBAFJKM, colloquially called "Oh Be a Fine Girl, Kiss Me." The system devised by Annie Jump Cannon, modified over the next 2 decades, remains the backbone of how scientists classify stars to this day. Annie Jump Cannon classified nearly 400,000 stars in her lifetime, an achievement that would have only been unimaginable a couple generations prior to her. Henrietta Olivia, a quiet, deaf computer, was a star amongst her Harvard computer peers. She found 1,000 variable stars in her career. Finding variable stars helped her notice a relationship between relative magnitude of variable stars and periodicity. Within a few years, astronomers used variable stars in global clusters and nebulae to calculate distances to objects in the galaxy. Henrietta Olivia expanded the frontiers of the Milky Way galaxy, and her law was just getting started. The words VAR represented variable star. Originally thought to be a nova, realizing it was a variable star came with an advantage. Edwin Hubble could now use Henrietta law to calculate the distance to that particular star in the Andromeda Nebula. His finding? 1,000,000 light-years. Thus, he realized Andromeda was not a nebula within the Milky Way galaxy, but it was a whole another galaxy on its own. Humanity's frontiers expanded forever using Miss Leavitt's technique. Our star distance measurement expanded from 300 light-years to 60 million light-years, a 200,000-fold increase. Scientists assumed that stars are made of the same substance as planets because the star spectrum had all elements found on Earth. Cecilia Payne, who joined Harvard in 1923, expanded on Indian physicist Meghnad Saha's work linking the spectrum of atomic ions to stars. Using his technique, Cecilia Payne painstakingly found a spectrum of neutral silicon with 1 and 2 less electrons in the overall spectrum. Breakthrough, Cecilia went further and mapped the availability of all elements in stars. She concluded that stars were made primarily of hydrogen and helium, and stars were different from planets in composition. Her conclusion was radical and a new frontier in space, and took famous astronomers at least 5 more years to accept Cecilia's conclusion. Women not only contributed to science, but the funding of the Harvard Observatory. Two of their biggest benefactors, Catherine Bruce and Anna Draper, gave nearly $600,000 to the observatory. Catherine Bruce gave $175,000, including sponsoring the 24-inch telescope. Mrs. Draper gave over $400,000 to memorialize her husband, Henry Draper. With their support and those of Harvard Computers, 3 awards were created: Catherine Bruce Award, Draper Medal, and the Annie Jump Cannon Award for Women. In 1943, Antonia Maury won the Annie Jump Cannon Award. Harvard Computers expanded our universe forever. The nearly 500,000 glass plates expanded our understanding of the universe to nearly 600,000 stars, 30,000 galaxies, 20,000 variable stars, and novas. The Harvard Computers created the foundation of star distance measurement, star classification, and star composition. The enormous work of these Harvard Computers created a frontier in astronomical publications. Edward Pickering started circulars to publish William Fleming's findings. Harlow Shapley created Harvard monographs for in-depth studies, with Cecilia Payne's PhD thesis on stellar composition being the first publication. None of the Harvard Computers won the Nobel Physics Prize. In 1925, a Swedish member of the Royal Academy of Science wrote to Professor Shapley about nominating Henrietta Leavitt for the Nobel Physics Prize. Henrietta was dead for 4 years, having died in 1921 of cancer at the age of 53. While little recognized by her peers in the scientific community, the general public knew very little of the Harvard Computers, and it's time for the Harvard Computers to get their own Hidden Figures Renaissance. Understanding dark energy and dark matter is the pursuit of modern cosmology. With so many telescopes producing mountains of data, modern astronomy can learn a few tricks from Harvard Computers a century ago. Even our incomplete understanding of our universe wouldn't have been possible without the frontiers breached by Harvard Computers, and thus our incomplete universe.